This is my new upcoming game Twisted Waters, and it has the most realistic water bending you've ever seen. Realistic water is one of the hardest things to render in computer graphics. Its liquid shape and transparent appearance makes it challenging to capture. We have seen it done in live-action movies, but even with the best hardware, it can take hours to render. So how is it possible to render realistic water in video games in real time? I have had the same question, so 6 months ago I started researching this matter in an attempt to make the best possible water bending game with responsive and physically correct water. Hey, it's Tamara here. I grew up watching series like Avatar: The Last Airbender and H2O Just Add Water. There is one thing they have in common: the ability to control water. I have spent an embarrassing number of hours pretending that I could control water. I don't do that anymore. Mostly. But hey, I'm a game developer now. I can make a game and pretend I can waterbend there. As with any indie game, it has to have lots of features, a great story, a huge open world, and in this case, super realistic water. So let's get to work. But why is the water in games so hard to make? And I'm talking about realistic water, not that blue substance that symbolizes water. Transparency, refraction, caustics, reflection. All of these things are complicated, which makes the water kind of a nightmare to render. But despite all of these things, we have seen incredible water in games. So what is the problem? The water usually seen in video games is a mesh surface with a bit of wiggling for waves and a shader for the color. It can look incredibly good like in Sea of Thieves or bad like my first water shader, but it's still just a plane. The technique behind water is specifically tailored for a horizontal plane, but the way water looks mid-air is very different. It can take any shape, it splashes, it pours. There is, however, another way to render water: fluid simulations. I became obsessed with water simulations. I watched them over and over again. I wanted that kind of water in my game. So I got a sample project off of the internet and it barely ran on my computer and was the optimized version. I was losing hope. And then I saw this. Unreal Engine already had fluid simulation wrapped in a pretty box just staring at me, calling me to try the 60 FPS. But I was a Unity girl. I didn't know anything about Unreal. And then the Unity pricing disaster happened, so I finally gave in and decided to try Unreal Engine. Things didn't go well from the start. So this might as well be the end of my Unreal journey. My graphics card is super bad. Like, I knew that it was bad, I just didn't realize how bad it was. I was really sad for a bit, but then I picked myself up, put everything on the lowest settings and got to work. So I worked in Unreal for just a few days, 3 to be exact, and I already have kind of like a working prototype of what I'm trying to do. And I really can't believe how fast I was able to get it up and running. The progress was slow because there was not much documentation on water in Niagara fluids, but thanks to Asher Zhu, who works in Epic Games and blogs about Niagara fluids, I managed to make it work. There was just a small problem though. Quick lesson on water simulations. They mostly run on the principle that many particles make up the water body. Each particle influences others based on their proximity. But checking that for all the particles is a lot of work. So researchers decided to manage particles in a grid and check those in the same cell. They also put these calculations on GPU to run them in parallel to cut down the time even more. But the simulation domain is still limited by the size of the grid. Could be significantly larger on a powerful graphics card, but in mine it just wasn't. I had to add some smoke and mirrors. What if I could have one water domain that would move along with the player and another one that would be the source of the water, and then I would just sync them up on intersection? And it worked! But the more I stared at it, the more I realized that I didn't like it. The shape of the water was boring, it had an unnatural color that got darker when the water was lifted, and it had a weird reflection on the bottom. I couldn't believe that I had spent so much time figuring out Unreal to just end up here. And that was it for me. I was done with the water simulation. But I still wanted to make the game. I just had to add more smoke and more mirrors. So let's start from the beginning. I decided to make the water look amazing on a static mesh. If I can have the simulation, at least the water would look great. And it looked like shit. Literally. so I had to try harder. I had to become an expert in shading. I even got a cat because every respectable game developer has a cat. I'm not exactly a master of materials, but the cat is cute and she does help me. The sphere was starting to look like a water ball. There was just something missing. The movement. When I was creating the look of water, I used glass as a reference, but the water is the element of change. It has to flow and respond to every move the player makes. And I wanted it to interact with the world when it was dropped. I didn't want a pre-made animation like you see in other games. I found out that I could use vertex displacement for movement, much like it's used for waves on a water surface. And the water became alive. There was just something off about it, you know, apart from floating with no gravity. Wait, no gravity? Water in space is basically waterbending. So I found these clips from NASA with water in zero gravity, and turns out I needed to add some jiggly physics. One down, more to go. Now, how do I make the water splash when it hits the ground? The only way to achieve that is with particle collisions, but that's almost the same as the water simulation. So I thought, why not just go back to it, but use it very cautiously. I also realized that I was previously simulating around 200,000 particles, so of course my computer crashed. But up to 10,000 particles was totally fine, and that's all I really needed. I didn't even need to put my project on the lowest settings. At last, the water was ready for the world to see. So that's not it. How can we have waterbending without Katara's signature water whip? So back to brainstorming. Fun fact, in the Greek dubbing of Avatar, Katara's name is actually Tamara, because Katara means a curse in Greek. A whip is basically a water trail. Trails are fairly common in games, but the way they're usually done is not fitting for my realistic water. The answer to this problem lies in fluid simulation. The simulation itself is just calculations of points with nothing on the screen. It can be visualized as spheres, but it doesn't produce that seamless look of liquid. So what is it then? Metaballs. These are seamless blobby objects created with some math magic. The thing is, they can be used without the simulation, and they're much cheaper for performance, so I can have my water ball made completely out of particles. After some strenuous thinking about the whip shape, the water was finally ready to show. And this is how it looks in the game. It performs pretty well even for my computer. There is still a lot of work to do, but that's where you can help me. First of all, Twisted Waters already has a Steam page where you can already wishlist it. Secondly, from now on I will be posting my game development progress on social media, so you can tell me right away what looks best in the game. Make sure you follow me. All the links will be in the description. And I want to thank everyone who supported me on Patreon, especially Ragvet Chivan, Andrea Team, Hylan, Luki Singles, Niels Weber, Michelle Pin, Jiwanan, Ava Gardner, GHXSD, Ahmed Orfaev, Marvin Bunges, John Park, Alexander Petro, Jeanette Resigoe, Prog1284, Daza Darawa, Daniel Ciccone, Bisa, Mike, Suing Gang, Richard Bollengay, Ozan Rizabaskert, Lauren Dressel, Felix Goldschmidt, Blua Ama, Miguel Querol Belja, Colin, Eris Strauss, Quincy Lambert, Richard Lowenstein, Junior Antian, Lunar 6, Boss, Sylvia Muir, Chin Chin Shu, Lewis, Paul Kwachan, James Slade, The Bears That Play the Cello, Mike Oroluva Collins, Sang-Ho Lee, Jacob Sorensen. And that's it for this video. Thank you for watching, and I'll see you next time. Oh, and I was trying to cosplay Azula, but I think my bangs look more like Tylese.